Alright, so this is Algebra 2, Lesson 3-7. Today's date is Monday, October 21st, 10/21, 2019. We're doing some factoring review, so everything that we've ever done all at the same time now. So I can be giving you guys a difference of squares, a sum of squares, advanced ninja star, normal ninja star, 4 terms. All of that is free game now. You should be comfortable factoring all of that, at least a 3 or above in terms of your fist of 5, and you're just going to be practicing it more. The hard thing is identifying what rule you're supposed to use. So, who can read our objective? Quiet raised hand. Our first hand goes to Caroline.
Factor polynomials with 2, 3, and 4 terms using a variety of strategies.
There it is. All right, so the first thing that you should always try to do, you might not be able to, but you should always try to do what? 3 letters. Lorea? GCD, there it is. Or GCF. I don't know what I'm saying. Greatest common factor. She said it correctly. Always try to factor the greatest common factor. That should always be step number 1. From there, it goes off to depending on what type of problem it is. So we have 4 examples, and then we just are going to get let loose for the homework. Tomorrow's quiz, by the way, I'm planning on doing it on Khan Academy unless some catastrophe happens like a power outage or it was totally the wrong quiz.
Are we having a quiz next week too?
Yes. So we need to factor this thing completely. So Chewy, Colby, you guys should be paying attention to the notes and closing the laptop. Thank you, thank you. Everyone's laptop should be shut. So everything is already being multiplied, so I now need to factor this x squared minus 9, that should factor into 2 things, and this x squared plus 4x plus 4, that should also factor into 2 separate things. So I need a quiet raised hand to just factor the left-hand side, x squared minus 9. It's very similar to the warm-up problem number 2. How do I factor the left-hand side? I need you to identify what it is first, and then tell me what to do. Anna.
So, difference of squares. So, do x plus 3 and x minus 3.
There it is, x plus 3 and x minus 3, because it is a difference of squares. Well said, Anna. And your card is in now. Thank you for passing it around. And the next one. First, what do you call that thing? What tool are you going to use to solve it? And what does it factor as? I guess it doesn't really matter what it's named. I can help with that. India?
It's the square first, double the second square, the last one, and you do it backwards.
You do indeed.
And it'd be parentheses x plus 2, parentheses squared on the outside.
There it is, x plus 2 quantity squared. So you could have written that as x plus 2 times x plus 2, or more condensedly, you can just write it as x plus 2 quantity squared. Question, Anna.
So, how does this work? The square, double, square?
So the way that you can check that this is a sum of squares is by taking the square root of the first and last terms, which would be x and 2, multiplying them together, x times 2 is 2x, and then doubling it. 2x times 2 is 4x. So you can't tell us the difference of squares. If you are ever confused and you have 3 terms or even 2 terms, it doesn't work with 4 terms, use Advanced Ninja Star. Let me come off to the side. If you are ever confused with 2 or 3 terms, Advanced Ninja Star will work. The only thing it doesn't work on is 4 terms down here. With Advanced Ninja Star, I take the middle term, 4, bring it down to the bottom. 4 times the coefficient of 1 is just 4 on the top. I leave this as x and x. I ask myself, what multiplies to 4 and adds to 4? The answer is 2 and 2. X plus 2 times x plus 2 is x plus 2 quantity squared. So you don't necessarily need to know the trick for how to factor a perfect square, but you do need to know how to do an Advanced Ninja Star at the bare minimum. I would say 3/4 of the time Advanced Ninja Star will work. The one time it won't work is problems like example number 2. By the way, we're done with example number 1. That's as far as we can go. So box it. All right, example number 2. I know that Leo is our resident expert at doing these types of problems. I'll give you guys 20 seconds to try it out on your own, and then we'll come back and regroup. If you want to work with your neighbors, you may. Go for it, 20 seconds. All right, is there anyone that wants to give it a shot? I see 2 hands. I am curious about how Leo would explain this, though, because I haven't heard him talk about these yet. You want to try it, Leo?
Yeah, next.
No? Okay. Anna.
Okay, so you have to group it so the first two terms and then the last two terms,
Okay.
and then you have to find something that will make the first two terms simplified and equal the same thing as the last two terms simplified.
Okay, I'm seeing.
In that case, that would be 1. Well, positive 1 for the first two, negative 1 for the second two.
Okay.
And then you'd have, so 3x plus 4, or I guess it would be 1x for the first one, because we have to simplify out the 3x.
Okay, so you want to add an x right here?
Yeah.
Okay.
So then you'd have 3x plus 4, because the 1x cancels out the x squared.
Careful. So in order to cancel out an x squared, we need an x squared.
Okay, so we do x squared next to that.
Okay.
And then there we just have 3x plus 4.
That is a perfect first step. I'm going to pause right there, make sure that everyone can get caught up. Right now, Anna is doing the strategy of trying to make sure that I have similar groups. A group of 3x plus 4, another group of 3x plus 4. As long as those two groups are the same, everything else should follow.
Wait,
Question? So this was normally negative 3x minus 4. In order to make sure that this group and this group are the same, I have to either multiply the first group by negative 1 or factor out a negative 1 for the second group. And Anna chose to factor out a negative 1 for the second group to get a positive 3x plus 4 and a positive 3x plus 4. This out front right here. So technically you don't even need the 1 in front of this. You can just say x squared. In order to make this a 3x plus 4, I have to factor out an x squared. So the question is always, what do you have to factor out of each of these two halves in order to get the same group, 3x plus 4 and 3x plus 4 in this case? You just need to make sure that these two groups are the same. This one was the easiest way to get their 3x plus 4 and 3x plus 4. Usually there is some right answer for what the group should be. Like for example, there's no way that I could have got 2x plus 7. There's just nothing in here that leads me to that. All right, Anna, can you finish that off for us?
So then you do x squared plus x squared minus 1. Then you do 3x plus 4.
Perfect. So I'm going to pause right there and make sure that everyone can see what happened. Ask me questions now.
Yeah, he does that.
Chewy Hood. We're not done. We're not done. We have one final step. This step is the most often forgotten. Aurelio, please stop talking. This right here on the left can be factored further. Who sees it? Quiet raised hand. X squared minus 1 can be factored into quiet raised hand. Aurelio, yeah, go for it.
X plus 1, x minus 1.
There it is, x plus 1 and x minus 1. Aurelio saw this. This was a difference of squares. Difference of squares factors into conjugate pairs, and I still have the 3x plus 4 on the right-hand side. And there's our final answer. So be careful. Make sure that you can't reduce or you can't factor anymore. Thank you, Aurelio. Questions before we move on to example number 3? Beverly?
Wait, how do you know, like...
How did we know that x squared minus 1 can be factored further?
Yeah.
Because you always have to stay on the lookout for difference of squares and for sum of squares. This was a difference of squares. X squared is a square, 1 is a square. Remember that one lesson where we just practiced trying to find squares? You might have been gone that day. I'm not sure. But we did 2 lessons on just finding squares, and you have to just always look for them. As a general rule of thumb for all of us, if you have something with an x squared in it, generally speaking, you can probably factor it more. So I'll write that off to the side too. And this is not a hard and fast rule. It doesn't work 100% of the time, but usually. So I'll write the word usually. So usually, if there is an x squared, you can factor more, or you can keep factoring. Jaden, please stop talking.
Sorry. It's about math. I don't see
Okay. All right, we're on to our second to last example, example number 3. We need to factor this thing completely. Again, I'll give you guys about 30 seconds to a minute to try this out for yourselves. Again, your first step should always be factor out the GCF. You should always be looking for that. Good luck. So, what is the greatest common factor? Quiet raised hand. Who can factor that out for me? I only see 2 hands out of a classroom that is much larger than 2. Who saws their card? Beverly. 5? Oh yeah, so 5. Oh, 5 parentheses.
I don't know if she's right. X to the 4th? Wait.
X to the 4th for the greatest common factor? Okay, yeah, x to the 4th.
4x squared
Minus 9. And how did you know that the greatest common factor was 5x to the power of 4? Can you talk us through that one more time?
because 5 I think 5 is the greatest common factor.
Of the coefficients, I agree. Between 20 and 45, the greatest common factor is 5.
The smallest exponent.
And the smallest exponent between x to the power 6 and x to the power 4. X to the power 4 is smallest. Perfect. Next step. Next quiet raised hand. What do I do from here? India.
Then there is I forgot the name.
Difference.
Difference of squares. So it's going to be 5x to the 4th, parenthesis, 2x plus 3, parenthesis, 2x minus 3, parenthesis.
There it is. And there, can we factor this any further?
No, because the 3 doesn't have a square root.
Yeah, exactly. 3 doesn't have a square root, neither does 2. They're not perfect squares. So there is our final answer, and that box could have been slightly better. All right, we have our final example question, Jaden.
After the lesson, can I ask a non-related math question?
For sure, yes. All right, so again, example number 4, you're going to try it on your own. It's the hardest, I think, did I add multiple steps? I guess we'll see, but it is definitely one of the harder types of questions that I can be asking you on the quiz tomorrow. Good luck. All right, so example number 4, quiet raised hand. What are my first few steps? Only one person knows. Colby.
Put the first 2 terms and the second 2 terms in parentheses.
All right, first 2 terms and second 2 terms are now in parentheses. One more step.
For the first quantity, factor out 9x squared, and for the second one, factor out -4.
9x squared. Again, just to make sure that everyone else is following along, Colby is finding the greatest common factor of this pair of parentheses and this parentheses. And he said 9x squared is the first one and -4 is the second one. I'm going to stop right there so that someone else can do that. Thank you, Colby. Jaden.
Okay, can I?
Yeah, go for it.
Okay. So after this step, I have 9x to the 2, whatever like you have. And then inside I have 2x plus 3.
Which means if I have 2x plus 3 there, I should have...
And also on the other side.
All right. And just verifying -4 times 2x is -8x, -4 times 3 is -12. We have the same 2 groups. This is factoring by grouping. Thank you, Jaden. Now what do I do? Next step. I need to go get one today. Next up, India.
Next up, you're gonna put the two terms that you divided them by into the parentheses together. So it's gonna be 9x squared minus 4 inside a parentheses, and inside the other parentheses 2x plus 3. But that's not the answer because we have a difference of squares in the first one.
Perfect. We'll give that to someone else. Thank you. India has identified that we have a difference of squares. 9x squared and 4 is a difference of squares. So who can factor this completely? Oh no, I think you've done it twice today, right? Beverly, I think you've only gone once. Yeah, we'll go with Beverly.
3x minus 2 plus 2
Plus 2, okay.
parentheses again 3x minus 2 and parentheses 2x plus 3.
There's our final answer. Thank you. All right, I need you guys to give me a fist of 5 on combining all of these things all of a sudden. How well do you think you can do these types of problems now?
I'll give you like a 3.5.
A 5, a 3.5 from Aurelio, a 4 from Cheyenne, 4 from Beverly, a 3 for Sam, 3 for Caroline, 3 for Brian, 4 for Anna, 3 for Chewy, 3 for Atziri, 3 for Colby, 4 for Leo, 3 for Sam. Jane, what are you at?
Like a 3.
A 3? Okay. Yeah, those numbers should go up after a little bit more practice. Are there any questions before we end the notes? Question, India.
For every term, for like 2 and 3 terms, is it always safe to be able to use Ninja Star?
For 2 and 3 terms, Advanced Ninja Star will always work, yes.
Okay.
As long as it can be factored.
Okay.
Yeah, good question. Any other questions? All right, good luck.